Assalamu alaikum. Welcome back to my channel Knowledge Ki Duniya. Today we will discuss about intermolecular forces. As we discussed before about different type of forces that are established between atoms, molecules and substances and compounds and elements. But here are some other types of forces that are very much important for the bonding of elements and compounds. Before starting the video, please subscribe my channel and like my videos, and don't forget to press the bell icon to receive notification of new videos. Let's start the topic. Intermolecular forces. As discussed earlier, the forces that hold atoms in a compound are chemical bonds. As we know that the forces that hold the atoms closer to each other are called chemical forces or chemical bonds. In addition to these strong bonding forces, relatively weak forces also exist in between the molecules. These bondings or these forces, two forces are also available: relatively weak forces and strong forces. Okay, and these weak forces between the molecules are called intermolecular forces. These forces are known as intermolecular forces, and today we will discuss about the types of intermolecular forces. The bonding and the intermolecular forces of hydrochloric acid are shown below the picture. As we know that chemical bond, we see in this diagram H partial positive make bond between chlorine and other compound HCl and other one HCl, and these three compounds make chemical bonding through intermolecular forces, and these three intermolecular forces are too much weak. Chemical bond are too much strong. Similarly, intermolecular forces at the same rate remain weak, and these intermolecular forces are very useful to make bonding between substances or molecules and compounds. As we know, here we will see about the HCl that are three HCl that are making bonding between these three between themselves through the intermolecular forces. It requires about 13 kilojoule energy to break these intermolecular forces between one mole of liquid hydrogen chloride molecule to convert it into gas. It means that if we break these intermolecular forces, we need 13 kilojoule energy to break these intermolecular forces, and 1 mole of liquid hydrogen chloride molecule to convert it in gas, and we need 1 mole of liquid hydrogen chloride. Okay, whereas about 430 kilojoule energy required to break the chemical bond, and as well as similarly at the same rate to break the chemical bond we need too much energy to break chemical bonds, which is 430 kilojoule for the same bonding of chemical bond between these molecules HCl, and this energy is 430 kilojoule energy required to break the chemical bond between hydrogen and chlorine atom in 1 mole of hydrogen chloride. And these two energies are in these two energies there are too much differences. These differences said that intermolecular forces are too much weaker than chemical bond. Chemical bond are too much strong, and intermolecular forces are too much weak, and we can break intermolecular forces very easily, but to break chemical bond we need too much energy. As we know, to break the bond between hydrogen and chlorine we need 430 kilojoule energy. Next are the interaction or intermolecular forces that we establish or that are present in different molecules and compounds. First one is dipole-dipole interaction. All intermolecular forces, which are collectively called van der Waals forces. As we know, all the forces, intermolecular forces, are called van der Waals forces. are electrical in nature, and these all forces are electrical in nature. They result from the attraction of opposite charge, which may be temporary or permanent. And these electrically in nature because of the attraction of opposite charges. Due to the opposite charges, electrical energy is established, and this electrical energy would be temporary or permanent. The unequal sharing of electrons between two different type of atom make one end of the molecule slightly positive and other end slightly negative charged. It means that because of the unequal sharing of electrons, we know that if two molecules or atoms or compounds make bond, it is established due to the sharing of electron and uh, give and take of electron. And if the unequal sharing of electron established between two different type of atom make one end of molecule, then it make the one end of the molecule slightly positive and other end and negatively charged. Okay, as shared pair of electron is drawn toward more electronegative, then the sheer pair of electrons are the so much negative in nature, electronegative in nature, sheer pair electrons. Okay, it is partially negative charge, and it is partially, as we know, it is partially negative charged as chlorine in hydrogen chloride. For example, in chlorine, hydrogen chloride, chlorine is partially negative and have a share pair electrons. The other end automatically become partially positive charge, and if one end is partially negative, then we know obviously the other end would be partially positive. When partial positive and partial negative charges exist at different position in a molecule, if the partial positive and negative charges exist or places at different position, then the molecule the adjacent molecules will arrange themselves in such a way that negative end of the molecule comes near to positive. Then itself they itself make their positions that the positive and negative end come closer to each other and can be easily to attract each other. Okay, it result in a net forces of attraction. It results, and then the net forces of attraction between positive charge and the two adjacent molecules. Then the positive forces of attraction established between two molecules or two pole. Okay, these attractive forces are called dipole-dipole interaction, and these interactions are called dipole-dipole. It means that the two different charged ion or atom come closer to each other or arrange in such a way that they can attract each other due to the opposite signs or charged. Here the example of HCl. HCl, you can see in this diagram, HCl, H is partial positive and chlorine and Cl is partial negative, and they opposite in charge, and then they make the opposite attraction and attracted due to the opposite charge. Next one is hydrogen bonding. Hydrogen bonding is a special type of intermolecular forces present in the permanently polar molecules. Hydrogen bonding is very much special intermolecular forces because it is present permanently in polar molecules. This bonding can be considered unique dipole-dipole attraction. It would be said that it is the unique dipole-dipole attraction. This force of attraction develops between molecules that have a hydrogen atom bonded to a small, highly electronegative atom with lone pair of electrons, such as nitrogen, oxygen, and fluorine. And this force of attraction develops between those molecules that have a hydrogen atom bonded to a small bonded which one is bonded with a small and highly electronegative atom with the lone pair of electrons, that the atom that have a lone pair of electrons, such as nitrogen, oxygen, and fluorine. The covalent bond between hydrogen atom and other atom becomes polar enough to create a partial positive charge on hydrogen atom and a partial negative charge on the other atom. Next one is the small size and high partial positive charge on the hydrogen atom enable it to attract highly electronegative atom of the other molecules. It means that the hydrogen have the too much frequency that it can attract the partial negative electron, and it can attract the lone pair of electrons that have a lone pair. Next one is so the definition of hydrogen bonding is partially positive charged hydrogen atom of one molecule attract and form a bond with the partially negative charge atom of the other molecule. The bonding is called hydrogen bonding. The hydrogen bonding is that in which the hydrogen make the bonding with the other atom of the molecule, and this bonding is too much strong. This force of attraction is represented by dotted line between the molecules as shown as below. Okay, hydrogen bonding affect the physical properties of the molecules. Hydrogen bonding affect the physical property of molecule. Due to this, boiling point of compound are affected greatly, and due to the irregular due to the physical changes, and the boiling point of the compound are also greatly affect. For example, boiling point of water is 100 celsius is higher than of alcohol because of more and strong hydrogen bonding in water. For example, in this example it said that the water have hydrogen bonding. Okay, and it is intermolecular force. So due to the heat, we can separated hydrogen with the oxygen, and the hydrogen water has a 100 celsius boiling point due to the hydrogen, and it is greater than the boiling point of alcohol 78 celsius because of more and strong hydrogen bonding in water. The important phenomena of floating of ice over water is because of hydrogen bonding. Next property is this: the phenomena of floating. As we know, the ice is float over water. It is also because of the hydrogen bonding in the water. The density of ice at 0 celsius is 0.917 gram minus 3. The density of ice is 0 and is less than that of liquid water at 0 celsius. In the liquid state, water molecules move randomly. In liquid state, water move randomly in irregular positions. However, when the water freezes, the molecule arrange themselves in an ordered form. And when the water becomes in a solid state, then they arrange the molecule in a very irregular order that gives them open structure. Then it gives a open structure. This process expands the molecule that results in ice being less dense as compared to water. Uh, uh, s- we can see here the yellow box. We can see the last question: define intermolecular forces and show these forces among HCl molecule. And this question come into a paper or a test about intermolecular forces, and the student should remember it very well. This is the topic about intermolecular forces. If you like this video, press the my video, and subscribe my channel, and don't forget to press the bell icon. Then we will meet in next video about a different topic.